Hey, this is Mr. Masonette, and what we're going to do in this tutorial is we are going to practice solving problems that involve linear functions. So let's take a look at this first problem. We are being asked which set of points is part of a linear function. Well, to figure out which one of these sets of points would form a linear function, all we really have to do is graph each set of these points and see if it forms a straight line. So let's go ahead and plot each set of points on the coordinate plane and see if it does form a straight line. So let's start with this set of points. The first point is positive 6, negative 2. The next point is 8, 0. And then we have 10, 4, which would be right here. And then what we're going to do is connect the points. But we can see that these 3 points do not form a straight line because this point is not part of this line. Or we can also say like, this point is not part of our line. So let's go ahead and plot the next set of points, starting with positive 1, negative 1. And then we have 3, 0. And next we have 1, 5. And we can clearly see that these 3 points will not form a straight line. So let's go to the next set of points, which is negative 2, negative 1. Negative 1, positive 2, and 0, 5. All right, well, it looks like these 3 points do form a straight line, so let us go ahead and connect these points. And we can clearly see that a straight line is formed by these 3 points. So we would say that this third choice is the right answer. Now, another way that we could have determined whether or not this is the right answer is by forming an XY table and putting these points into our table like this: negative 2, negative 1, negative 1, positive 2, and 0, 5. And then checking to see if we have a constant rate of change. So if we go from this Y value to this Y value, we would say that the Y increased by 3. And the corresponding X values increase by 1. And then from this Y to this Y, that is also an increase of 3. And from this X to this X, that is an increase of 1. So we would say that the slope or rate of change of this linear function would be 3 over 1. Remember, the change in Y is your numerator and the change in X is your denominator. So we have a slope that is 3 over 1, which is consistent. Now, if you were to take a look at another choice, let's say this one right here, if we started with the change in Y, we went from negative 2 to 0, that is an increase of 2. And then from 0 to 4, that is an increase of 4. And then if we look at the corresponding change in X, we went from 6 to 8, which is an increase of 2. So for the first 2 points, we have a change in 2 for the Y, a change in 2 for the X, which would be 2 over 2. But between these 2 points, if we go from this X to this X, that is a change in 2. So the slope between these 2 points would be 4 over 2, which is different than 2 over 2. So we have different rates of change here. All right, let's go ahead to the next problem. So for this problem, we have to determine which of the following is a graph of the equation y equals negative x. Now, one thing that we should remember about all variables in an equation is if you do not see a number in front of that variable, there really is a number 1 in front of that variable. So I can read this equation as y is equal to negative 1x. So the coefficient of x is negative 1. And because this is a linear equation, we would say that this coefficient here of x is the slope of our line. So we would say that we should have a line with a slope that goes down 1 and goes over 1. The rise is negative 1 and the run is positive 1. So all we have to do is figure out which one of these lines reflects this rise over run. Now notice that we have no y-intercept at the end. Well, we shouldn't say we have no y-intercept. We should say that the y-intercept is 0 because there is no number after the x. So we know for sure that our line is going to intersect the y-axis at 0, which would eliminate this choice and would eliminate this choice. So it must be one of these two graphs. Now notice that our slope is negative. That means from left to right, our line must be going downwards. So it has to be this choice right here. Now we can also see that this line has a slope of -1 or -1/1 because if we plot a series of points directly on our line, we can see that we go down 1 and over 1 between each point. All right, let's go ahead and do another problem. Okay, for this problem, we have to determine which of these tables would demonstrate a nonlinear function of x. Meaning if we were to plot these points on the coordinate plane, they would not form a straight line. All right, let's go ahead and see if this table represents a linear function or a nonlinear function. So the first point is located at -6, 0, which is right here. The next point is -5, 2, -4, 4, -3, 6, and -2, 8. And we can clearly see that these points would form a straight line, so it is a linear function. All right, let's test the second table here, starting with -3, +3, -1, 6, 1, 9, 3, 12, and then the last point is 5, 15, which would be about right here. And we can see that these points also form a straight line as the first example does. So let's go ahead and test the points in the third table. All right, the first point is -10, -7, which would be about right here, slightly off of our coordinate plane. -5, -4 is right here. 0, -1, which is right on the y-axis. 5, +2, which is right here. And 10, 5 would be slightly off of our coordinate plane as well. And we can see that these points do form a straight line, which means it must be the last choice, which is an example of a nonlinear function. But let's just go ahead and plot these points just to demonstrate this. So the first point is at -9, -1, -5, +1, -1, +4, 3, 6, and the last point is located at 7, 8. Now, if we glance at these points rather quickly, it might look as if they form a straight line, but upon further inspection, we can clearly see that they do not. If we were to connect these points here, we can see that the rate of change is up 2 over 4, which can be reduced to up 1 over 2, or 1/2. So the rate of change between these 2 points is 1/2. But then if we take a look between these 2 points here, we would have to go up 3 and over 4, which is a different rate of change. And then between these 2 points, we would go up 2 over 4, which is 1/2 again. And from here to here is also 2 over 4, which is 1/2. So all points have a rate of change of 1/2 except for between these 2 points right here. So we have close to a straight line. This is still a function, but it is not a linear function. So we should have selected this last choice right here. All right, let's go ahead to the next problem. All right, this problem reads, what is the rate of change of the linear function with a graph that passes through the points 2, 9 and -1, 3? Express your answer in simplest form. Now, whenever referring to the rate of change of any straight line, what we're talking about is the slope of the line. And to find the slope of a line, we can go ahead and use the formula y2 minus y1 over x2 minus x1. Now, some of your teachers may refer to that as the vertical change over the horizontal change. because the y-axis is the vertical axis, which is up and down, and the x-axis is our horizontal line, which moves from left to right. And it is also referred to as the rise over the run. I like to call it the change in y values over the change in x values, delta y over delta x. So what I'm going to do is I'm going to take these 2 points here, positive 2 and 9, which is our first xy pair. So I am going to refer to this pair as x1, y1, and then label my second point, negative 1, positive 3, as our second x and second y. And then I'm going to plug these values into our slope equation. So I'm going to start by writing a minus sign at the top and the bottom. And we're going to start by subtracting our y value, starting with y2, which is 3 over 9. And on the bottom, we're going to subtract our x2, which is negative 1, with the x1, which is 2. So for the numerator, we have 3 minus 9, which is negative 6. And for the denominator, we have negative 1 and negative 2, which is negative 3. Or we can read this as negative 1 minus 2, which is also negative 3. Now, whenever you have two negatives in a fraction, what you have to do is change that to a positive. So we have 6 divided by 3, which is positive 2. So 2 is the rate of change of this linear function. All right, let's go to the next problem. This problem reads that Darius received a one-time $100 hiring bonus for starting a new job. The table shows Darius's hourly rate of pay, including his $100 hiring bonus. How much does Darius earn per hour? Now, let's be careful with a problem like this. I noticed students in the past will look at the column that says hours and look at where it says 1 hour and just automatically assume that the number right next to it is the answer. But that wouldn't make sense because there's no way Darius is making $130 per hour, because in 2 hours, that would mean he would make $260, which is double 130. So what we have to do is dig a little bit deeper. So what we're going to do is we're going to look at the rate of change, or the slope that would be formed by the line if these values were graphed on the coordinate plane. So let's take a look at our y column and examine how it is changing. If we start at $100 and go to 130, that is an increase of $30. And the corresponding change in x values is 1. And if we go from the next y to the next y, it would be an increase of 30 as well. And the hours also increase by 1. And this pattern continues for this table. So we should notice that every time that 1 hour goes by, that Darius earns $30 more. This is the change in y, which is 30, and this is the change in x, which is 1. So we would say that Darius is making $30 each hour. Now, the reason that the first entry is $100 for 0 hours is because without even working any hours, Darius received $100 for a signing bonus. And then from that point on, he was adding $30 more to that $100 that he started off with. All right, let's go to the next problem. All right, so the problem says that the following graph shows how much money Tiana is saving per week. And we have to figure out which of the following equations represents the amount of money Tiana has saved. So taking a look at this graph, we can see that our line crosses the y-axis at 20. This is going to be important because this is our y-intercept. And we also have to determine the rate of change, or the slope of this line. So I am going to locate other points on this line, like there's a point right here, and there is a point right here. And then what we can do is say that from 20, at this point, we would go up to 50 on the y-axis. So that is an increase of $30. And then from here to here, the change in x is 1. So the slope is 30 over 1. So how would that be expressed as an equation? Well, we always start off with y equals, and then after the equal sign, we write what the slope is, and the slope is up $30 over 1 week. So we would have 30 over 1. And we always multiply our slope by x, and after the x variable, we write what the y-intercept is, which in this case is positive 20. So we write positive 20 or plus 20 at the end of our equation. And what we should do is go ahead and just simplify this slope. 30 over 1 is really just 30, x plus 20. So the correct choice in this case would be this equation. Now, something else we should notice about selecting the right equation is if we were to take any point on this line right here and plug it into our equation, it should form a true statement. For example, let's take a look at this point here. We would say at 1 week, Tiana saved $50. So if we plug 1 week in for 30 and then add 20, we should end up getting y equals 50. So $30 times 1 week is $30 plus $20 would equal $50. So we can see that this equation does check out. If we were to plug this ordered pair into the equation, which is 280, we would say in 2 weeks, that would be an earnings of $60, and then we would add that to the 20 that she already has in her bank account. She must have had $20 to start off with because at 0 weeks, without any time passing by, she started off with 20. And from that point forward, this graph indicates that she is saving $30 per week because she goes from 20 to 50, 50 to 80, and then it would be 110 after that. All right, let's go to the next problem. Okay, what we have to do here is match each graph line with the type of slope shown. Now, this graph right here is a flat line. Whenever you have a perfectly formed horizontal line, that is going to have a slope of 0. Now, this line right here is going up from left to right. We always read our lines from left to right, and we can see that this line is moving upwards, which means it has a positive slope. Now, the graph of this line is definitely negative because this line is going downwards from left to right. And of course, this last line has an undefined slope because it is going up and down. So anytime you have a line that is going up and down, that is going to be undefined. A flat line or a horizontal line has a slope of 0, and a positive slope is moving up from left to right, and a negative slope is a line that is moving downwards from left to right. All right, let's move to the next problem. All right, this problem reads that a line passing through the point -7, +1 has a slope of 2/3. Which of the following points is on the line? Now, to solve a problem like this, my strategy is going to be to start by writing the point in this function table, the point that is given, -7, +1, and then take our slope and understand that the numerator is the change in the y values and that the denominator is the change in x's. Now, what that really means here is I can go to the first y entry, which is +1, and just start adding 2. And the reason we're going to add 2 is because this is a positive slope. So let's go ahead and change our y values by +2. So if we add 2 to that, that would give us 3. If we add another 2 to that, that would give us 5. If we add another 2 to that, that would give us 7. And another 2 would give us 9. Now let's go ahead and add 3 to our x value. So starting at -7, going up 3 would put us at -4, Increasing by 3 again would be -1. Increasing by 3 again would put us at +2. And increasing by 3 again would put us at +5. Now what we have to do is see which one of these points we entered into our table is one of the choices shown on the screen. So the only choice that we have here that appears in our table is +5, +9. So if we start at -7, +1, and increase the y values by 2, and increase the x values by 3, we can see that our line would definitely go through the location +5, +9 on the coordinate plane. All right, let's go to the next problem. All right, now this problem asks, which graph has a slope that is 1/2 unit greater than the slope of the graph y equals x minus 3? Now, y equals x minus 3 has a slope of +1. Remember, if there is no number being multiplied by the x, well, there really is. It is the number 1. So the coefficient of x is 1. So the slope of this line is +1. Now remember, slope is the rise over the run. So whenever you have a single digit or a whole number for slope, you can just go ahead and put 1 as a denominator. So we would say that with this equation here, the rise is 1 and the run is also 1. Now what we have to do is figure out which of these graphs has a slope that is 1/2 a unit greater than this slope of 1/1. So basically what we're doing is we are adding 1/2 to 1 whole. Now if we take 1 whole and just add 1/2, that would be 1 and 1/2. But slope is not expressed as a mixed number, so we have to rename 1 and 1/2 as an improper fraction. So we just keep the 2 as it is, and then what we do to get our numerator is multiply the denominator by the whole number, and then we add the numerator to that result. So 2 times 1 is 2 plus 1 is 3. So 1 plus 1/2 is the same thing as 3/2. Now another way we could have thought about this is that 1/1 is the same thing as 2/2. Now the only reason I would write it like this is so we can add it to 1/2 because they have like denominators. So 2/2, which is the same thing as 1 whole, plus 1/2 would be equal to 3/2. So what we're going to do now is search for which one of these graphs has a line with a slope of 3/2. So let's test this first choice here. So what we're going to do is plot points on this line and figure out what the slope is of this line. Now we can see that our slope is going up 1 and over 2, up 1 over 2, up 1 over 2. So this line has a slope of 1/2. So that is not what we are looking for. We are looking for a slope of 3/2. So let's go ahead and put some points directly on this line. And the slope of this line is going to be up 5/3, up 5/3. And 5/3 is not what we are looking for. So let's test the third choice. So we have a point here, a point here, a point here, and we can go ahead and see that the rise is 2 and the run is 3. So up 2/3, up 2/3. And 2/3 is not what we are looking for. However, we have to be careful because I see a lot of students mistakenly switch around the numerator and the denominator. Remember, the numerator, which is 2 in this case, is always the vertical change, how much you go up or down. The run, how far you go over, is always the denominator. So it must be this choice, but let's go ahead and confirm this. So we can place a point right here, and here, and here. And we can see that our vertical change is going to be 3. The horizontal change is 2. So up 3/2, up 3/2. So we have confirmed that this is the correct choice. All right, let's go to the next problem. All right, this problem reads that the following graph shows the rate at which a mechanic is charging to repair a car each hour. How much is the mechanic charging per hour? All right, let's start by looking at the x-axis and determining what 1 hour is. So we can see that an hour would be like from here to here, and then from 1 to 2. So as it relates to our line, the first hour would be from here to here. Now, over the course of that hour, we started at $40 and we went up to $60. So we would say that this person or the mechanic earned $20 over that hour. Now, from hour 1 to hour 2, we can see that we also go up $20 from 60 to 80. And that pattern continues because we have a constant rate of change. So from 80 to 100, that's an increase of $20. And we're at 2 right now, going over to 3 hours, which is 1 more hour. So we would say that the mechanic is charging $20 for each hour of service. Now, you may be wondering, why is this graph starting at $40 at 0 hours? Well, that may be because something like the mechanic is just charging an upfront fee of $40 just to reserve a spot or something like that. I have no idea why that is, but sometimes businesses or companies will charge some sort of service fee up front before they even start looking at your car or something like that.
Hey, I just want to say thanks for checking out this math tutorial. Please don't forget to hit that subscription button and activate notifications so you can be informed as I upload new math tutorials that just might help you with your math homework. Until next time, this is Shane Masonette with Masonette Math.